Hello, I'm Matthew Turner, author of the paper The Form of Uncertainty Affects Selection for Social Learning, co-authored with Cristina Moya, Paul Smaldino, and James Holland Jones. Learning is a way to reduce uncertainty about the world, and it is widely believed that learning from others is especially useful when one is uncertain. But is this true? It depends on what you mean by uncertain. Uncertainty could mean changes to the environment, making previously learned information outdated. It could mean a wider range of behavioral options, so it's harder to test all the possibilities. It could mean more noise in the signals themselves, creating confusion. Or it could mean fewer opportunities to gather new information. To study the relationship between social learning and uncertainty, we developed an agent-based model of behavior choice under these 4 common forms of uncertainty, where social learning could evolve to help inform agent decisions. We found that the value of social learning declined with greater environmental variability, but agents with more behavioral options evolved to be social learners, even in more variable environments. Let's now walk through the model. We model the environment and behaviors as a multi-armed bandit. The model illustration here shows a 2-armed bandit or 2 possible behaviors. The optimal bandit arm has the highest expected payoffs, while the other non-optimal arms have the same lower expected payoff. The probability that the optimal arm changes between generations is the first form of uncertainty, called the environmental variability. The second form of uncertainty is the number of bandit arms, called the selection set size. The third form of uncertainty is the number of times agents can try different behaviors, called the effective lifespan. The fourth and final form is the difference between expected optimal and non-optimal payoffs, called the payoff ambiguity. In the leftmost panel, the agents in the model are initialized without any knowledge about the possible payoffs from each behavior, but they do know how many behaviors are possible. Agents try different behaviors selected through softmax selection, updating the mean payoffs observed for each behavior as they get them. After the agent's effective lifespan is over, the most successful agents are preferentially selected to reproduce. The social learner agents incorporate information from others at the beginning of their life by preferentially selecting a successful teacher from the previous generation from whom they learn about expected payoffs. Asocial agents begin life with no knowledge about the expected payoffs. Our primary outcome measure was how frequently all agents evolved to be social learners. To very briefly summarize our analysis, we found that a greater selection set size on the x-axis in this plot increased the maximum environmental variability for which social learning evolved. We call this the social learning ceiling, which is on the y-axis in this plot. Payoff ambiguity affects both information quality and strength of selection, leading to increased social learning ceiling for the parameter settings shown here. This work helps explain why humans constantly engage in social learning despite increasingly high levels of environmental variability. Adaptive individual learning helps us recover from acquiring outdated social information. For more background information, in-depth explanation, and analyses, please see our paper. Thank you for your time and your attention watching this video.